Okay, I want you to see if you can do this. Draw a wave series and label as many of the parts as you can. Let's try that first. It's okay, just don't look back in your notes. Just see what you can remember. When you've labeled everything you can, count up how many things you've labeled. Anybody still drawing? Okay. Carter, can you tell me one thing you have on your wave series? The wavelength. Did you go crest to crest? Yes? Okay. Oh, that's bad. So if you don't have wavelength, fill it in. You can use a symbol if you want. Belle, tell me something you have on yours. What? Crest? Is that what you said? You're like this and talk loud. The trough. Okay. So there, she just gave us two. Really, you got anything else? No? Elise, anything else? Maddie? Okay, amplitude. I'll put amplitude down here. Alright. We're missing one thing. Carter? Frequency. And I'll just make my block for frequency right here. There. Now, honestly, how many of those things do you think you could define? Carter's laughing at me. Who can tell me what a crest is? Faith, can you tell me what a crest is? Yeah, the highest point on a wave. Versus a trough, Lindy. The lowest point on the wave. How about wavelength? Harley, can you tell me that one? Distance from crest to crest or trough to trough. Amplitude, Addie. Yeah, the distance from baseline to the highest point on a wave. This part right here, maybe we should write this down. That's called baseline. Anybody remember how to talk about frequency? Josh, if I asked you frequency, what would you tell me? Good. And we measure it in hertz, which means waves per second. Not too bad. All right, so now let me ask you another question since it's been a while since we've seen each other. Can you tell me the equation and it relates wavelength and frequency? Do you remember that one? We did some problems with it on whatever day that was, Thursday. What's the equation, Isaac? Can you tell me? C equals, what's that upside down? Y stand for? Lambda or wavelength. times what? Times nu, yeah, which is frequency. What's the speed of light? You should have that in your brain now. Yeah, 3 times 10 to the 8 meters per second. Wavelength units are meters. Frequency we just talked about, hertz. Okay. And we did, I think, a couple problems in your notes with that, yes? Okay. So the second light equation. I talked about it just a little bit. There was this guy, his last name was Planck, and he looked at the relationship between light in terms of wavelength, I'm sorry, in terms of frequency and energy. So he really wanted to find out about frequency and energy and how they go together. He basically does a bunch of experiments with light, and he comes up with an equation that looks like this. E equals H nu. Where E is energy, and it's measured in something that the symbol for it's a capital J, joules, yeah. That is the unit for energy in the metric system. This H stands for Planck's constant, which is the number that never changes. By studying energy and frequency, Planck found this relationship that gave him a constant. And it is 6.626 times 10 to the negative 34 joule seconds. That's a little dot, joule times second. So he found that when he studied this relationship between E and H, he always came up with the same number. So they named it after him. And obviously we know this is frequency, which is hertz, for waves per second. And that's important because those seconds are eventually going to cancel each other out. So it's nice. It's another straight line equation. So we're going to have 2. And I think probably on Thursday we'll have a little quiz over these equations and a couple of other things. Okay, so let's look at some problems. I'm just going to mix them up. We'll do a couple of the ones with Planck's constant first. So they look something like this. Calculate the energy of light with a frequency, make these short, of 4.5 times 10 to the 12 hertz. So the first thing you want to do when you get these problems, now that you have 2 equations, you want to look at what you're being given and what you're being asked for, and then figure out your equation. So you're being asked for energy, and you're given hertz. What does that tell me? What am I being given? Frequency. Even if I didn't say that, you should know it's frequency because of the hertz. So obviously we're going to use the equation we just got. This is actually a pretty easy question. You don't even have to move any variables around. Get your calculators out if you don't have them out. If you need one, come get one. Alright, so I'm being asked for E. In this case, I have one variable I know, 6.626 times 10 to the negative 34 joules times seconds, times my frequency, which I was given, 4.5 times 10 to the 12th hertz. Put these in parentheses in your calculator. Put your 6.626 times 10 to the negative 34th, hit enter, times, and then put this in parentheses. See what you get. We'll see if we all get the same thing. Annika, what did you get for an answer? 2, which I made 3, times 10 to the what? Negative 21. Now let me ask you this. What would your units be on this? Joules. How'd you come up with that, Carter? Yeah, this is like 1 over seconds here. So seconds, cancel out seconds. My hertz are gone because I just got rid of it. So my units are joules. The reason I can get rid of the whole hertz is because that's just like a 1 up there. It's like 1 per second. So we don't have to worry about that. Okay? All right, let's try another one. Calculate the frequency of light with an energy of, what shall we pick here? 3.98 times 10 to the 7th joules. Now, one thing I didn't do last time, which was not good, is I did not write down my variables, which I would expect to see you do. So we'll put our 6.626 times 10 to the negative 34th joule seconds. And I also know my energy, 3.98 times what? 10 to the 7th joules. Work it out. See if you can put your formula down and work it out. So if you're struggling with the setup, I had my straight line equation. I want to get v, or nu, by itself. In order to do that, I had to divide through by my 6.626 times 10 to the negative 34. If I do it to this side, then I have to do it to this side. That's the math rules. And then I have to punch it in my calculator, which I haven't done. Okay. Mara, you got an answer? 5.9 times 10 to the 40th. Is that what you guys got? And what would my units be? Hertz. Good. Joules cancel out. That's like a 1 over seconds. So hertz. Now, I'm going to give you one that's more of a challenge. Does this seem pretty easy? Okay, I'm going to put this up here. I would encourage you to actually write this question in your notes. And then see what you can do with it. I'm just going to give you a couple of minutes, and then we'll work it together. So if you're confused, just hang out, and I'll work through it. But see what you can do with it. See if you can figure it out. Let's do it anyway. This should be really easy. You just have to think back a little bit. When you have an answer, stand up. Or I guess if you can't get an answer. Raise your hand if you know what you're doing. Not too bad. Raise your hand if you're like, I don't know what to do. Nobody? Everybody has an idea? Okay, people, help me out. What are the two variables that I know for this equation? Carter, give me one. Frequency equals 4.6 times 10 to the negative 9 hertz. Isaac, what am I asking for? Wavelength, I don't know. Do I have a formula that puts those two together, Maddie? Yep, I do. C equals lambda nu. So I also know C, right? You guys told me that before. So this is just an equation from last Thursday, which is a long time ago. So let's plug it in and see what we get. 3 times 10 to the 8 meters per second equals wavelength times 4.6 times 10 to the negative 9 hertz. I'm going to get it off this side. Which means I have to do the same thing over here. 4.6 times 10 to the negative 9 hertz. Carly, did you put in your calculator and get an answer already? What'd you get? 6.5 times 10 to the 16th. Hertz cancels out seconds, which leaves me with meters. Yes? Now, you guys who weren't thinking about going back to the old equation, is that easy enough now? Now I'm going to give you one early as a challenge. The one I meant to give you last time. There you go. Try it. A certain form of electromagnetic radiation has an energy of 7.92 times 10 to the 12th. Calculate the wavelength. See if you can figure that out. What? Yeah, it has an energy of 7.92 times 10 to the 12th joules. And then I asked you to calculate the wavelength. Who has an idea of what to do? Annika, tell me what you're doing. She's going to find nu, she's going to find frequency. How are you going to find it? Use the first equation, right? Or use the second equation and find it. And then once you've got your frequency or nu, where are you going to take it and use it? In the first equation, C equals lambda V. So you have to use both equations to get to the end. When you have an answer, stand up for me, please. Let's see if we agree. And if you're confused, it's okay. I'm going to work through it. Okay, Faith, tell me what you got. Say standing if you got that. Okay. Okay. You got around that. That's good. I have 2.5 times 10 to the negative 38 meters. Now, who wants to see me work that? Anybody? I'll be happy to. Okay. This is how I would expect to see it on a test, for those of you who are quick with your math stuff. So I would expect to see E equals 7.92 times 10 to the 12th joules. I would expect to see H equals 6.626 times 10 to the negative 34th joules times seconds. And I would expect you at this point to go, I have to find frequency before I can find wavelength. Because you have to use what you're given. Over here, I would expect to see two equations. And I might as well go ahead and put in my 3 times 10 to the 8 meters per second. If I look at this, I can see I've got enough to use this equation. So I would say E equals HV, and I would say 7.92 times 10 to the 12th joules is equal to 6.626 times 10 to the negative 34 joules times seconds times mu. And I would solve through for mu. Now, did anybody write all of that out? Maddie, what did you get mu to be? 5.24 times 10 to the negative 21st. Did anybody else write that down? I'm going to punch it in and check it really quick. Yeah, okay. So I have 1.2 times 10 to the 46th hertz equals frequency. So there's my first part. So now I have enough information to come up here and use this equation. C equals lambda V, or 3 times 10 to the 8 meters per second equals wavelength times 1.2 times 10 to the 46 hertz. Get that off of that side. And over here. Just that. And I can say lambda equals, I'm going to forget what it was, 2.5 times 10 to the negative 38 meters. So it's a matter of working through both steps. Question? So you guys, you need to memorize two things. This is going to have to be memorized, and this is going to have to be memorized. Planck's constant and the speed of light. I'm going to give you one more question to work, and we'll be done. I'm not going to give you any homework today. I'll give you some more. The wavelength of a specific light is 4.7 times 10 to the negative 9 meters. Calculate the energy of this light. See how you do with that. Read it, decide is this, do I have to use both formulas, do I only have to use one? That's the first question you should ask yourself. One or two formulas, and then once you decide, you can figure out where to start. Be sure you list your variables and you list your equations. That's the only way you're going to get full credit when you do these. Oh, shoot. Okay, anybody get an answer? What'd you get, Annika? 4.2 times 10 to the negative 15. Okay, 17. Okay. Remind me, we'll check it tomorrow. You did? Okay.